Welcome back, everybody. So now we're going to look at actually graphing these rational functions. So last time we kind of talked about all of those characteristics of asymptotes that we could have, vertical, horizontal, and slant, holes, as well as kind of just looking for the normal things like intercepts and zeros that we normally do when graphing functions. So what we're going to do here is kind of go through each example and sketch a graph of the function. So we'll start with number one. Number one's pretty simple. We can see that nothing is going to cancel here, so this graph will not have any holes, but we're going to kind of look for all the other things. So in general, my recommendation is kind of organized somewhere, vertical asymptotes, horizontal or slant asymptotes, zeros, and maybe the y-intercept as well might be useful. So looking at our function here, we can see that there's a 0 at x equals -3. The y-intercept would be when x is 0. So if x equals 0, y is going to equal, well, we'll have 3 times 3 over 1, so 9. So 0, 9 is going to be our y-intercept. And then for the asymptotes, now we'll kind of look at those key features. So in our denominator, we've got this x plus 1, so that's going to be our vertical asymptote. So at -1, we are undefined, and we're going to have some sort of infinite behavior. And then for horizontal or slant, we're going to look at the leading degree here. So we can see that the leading degree is the same. And so if the leading degree is the same, then we look at the lead coefficients. So in this case, it's going to be 3x over 1x. Which means that our horizontal asymptote is y is equal to 3. And really, once we have these, we're probably going to have quite a bit of information. And so let's see what our graph is going to look like. So we'll note at -1, we'll use blue here. We've got our vertical asymptote at y is equal to 3. We're going to have our horizontal asymptote. So we can see that there's these 4 regions that are created with this graph. And then we're just going to plot those known points. So 0, 9 is clearly going to be somewhere above the red and to the right of the blue. And then the 0 of -3 is going to be at -3, 0. And then from here, we could plot some additional points. Right, so we could plot points at 1, at 2, but actually those 2 points that we have here are probably going to be pretty good in terms of determining the behavior. What we'll note is that this function doesn't have any symmetries. So again, we could kind of look at the expression here. We could see that f of -x is not going to equal the original function because we have odd degrees. And it's also not going to equal the opposite of our function. So we're going to run into some even and odd functions here, but this is clearly not one of them. So let's go ahead and choose a different color, maybe make a slightly thicker line here. So our graph is going to follow the horizontal asymptote, and then it cannot cross the vertical asymptote. Same will be true on the left. We'll approach our vertical asymptote but never touch, and then follow our horizontal asymptote. And so that'll be our graph. And really, this process is going to repeat for each graph. So let's go ahead and look at number 2. So again, we've got the same degrees here, so our horizontal asymptote work is going to look kind of similar. So again, we'll just kind of list off to the side here all of those key things we might look for. And we'll note that we've got mixed degrees here, even and odd, so there's no symmetry here as well. So this is not symmetric. So we'll note this is not going to be symmetric, but we can still graph it. So let's find those important pieces of information. So we're going to want to factor this. So we'll have 5 times x plus 3 times x minus 2 over, maybe we'll move our graph for later, 3 times x minus 2x minus 1. And we can see we've got a factor that's going to cancel, which means our graph is going to look like 5 times x plus 3 over 3 times x minus 1. So what we're going to add here, so we're going to have some holes. So we probably should have noted over here for holes, there are none. But here we're definitely going to have some holes. So we've got a hole at x equals 2. For our y-intercept, it looks like we're going to get negative 15 if we plug in 0. And then zeros, we're going to have x is equal to negative 3, and maybe we'll give that in intercept form also, since we're going to be graphing. So that's probably going to be helpful. So horizontal asymptote, slant asymptote, we've got a horizontal asymptote for sure, and it's going to be y is equal to 5/3, and then a vertical asymptote at x equals 1. So let's go ahead and put these on our graph. So we've got our vertical asymptote, we've got 5/3 is between 1 and 2, so we've got our horizontal asymptote. And then we've got some points. So we've got negative 3, 0 is a point, 0, negative 15, so down here. So we kind of know what the behavior is going to be on the left. So we've got those two coordinates. And then we have a hole at x equals 2. So again, we could plot some points over here. So maybe 2 or 3, and what we'll get is that if we have 2 or 3, we'll have positive numbers above 2. So we'll have 2 points like this. I'll leave it to you to kind of check those points. And then our graph, again, is going to follow the vertical asymptotes as it gets close, and then the horizontal asymptotes as we go to the right or to the left. And what we'll note, though, is at 2, we have a hole. So we're going to want to go back and just do a little deletion there and then put in our hole value. And again, the goal of these is to get the general shape. It is okay if it's not to scale or not the exact size. So the goal is to graph these kind of quickly to look at their behaviors. All right, so let's go ahead and look at number 3. So for number 3, we'll maybe start by factoring. So it looks like we're going to have x minus 2, x plus 1. And we're not going to have symmetry here because we've got an odd and an even and an odd kind of all mixed together. So you could check that. So there's no symmetry. So we'll just look for kind of those normal things. So vertical asymptotes, horizontal slant asymptotes, zeros, and the y-intercept. No holes. So our holes are going to be not here. But we'll have everything else. And in fact, we've got 2 vertical asymptotes. So x equals negative 1 and positive 2 are going to be asymptotes vertically. And then for the horizontal asymptote, we've got larger degree in the denominator. So this is going to be y is equal to 0. So that denominator is just going to get a lot bigger, a lot faster. And so the function is going to tend to 0. For zeros, it looks like x equals 0, so the origin. And then y-intercept is the same, right? So we don't really get any additional information since the y-intercept is the x-intercept. So we'll kind of look at this graph and see what we end up with. So we'll start with our vertical asymptotes. So we've got it at 2, and then negative 1. So now we've got 3 regions where we're going to have the graph. So we'll have 3 branches. We do know that 0, 0 is a point, and we know that y is equal to 0 is our horizontal asymptote, so it's going to tend towards the x-axis. And now we're probably going to want to plot some points because we don't really have a lot of information. So maybe we'll start in the middle so we can kind of figure out what's happening between 0 and 1, 1 and 2. So if I do h of 1 is going to be 1, over negative 1 times 2, so we get negative 1/2. All right, so we're going to get some value down here. So that's actually going to be enough information because we know in between we're going to be approaching our asymptotes. So to the left of 0, we're going to be getting larger. Now you could verify this by maybe choosing like negative 1/2, somewhere in between. But if you plug in negative 1/2, you will definitely get a larger positive number because you get a negative over a negative. So this graph is definitely going to tend towards positive infinity from the right at negative 1. And then it's going to pass through our negative 1/2 and then continue so that it almost has sort of an odd degree polynomial shape, sort of like a cubic sort of shape, but not exactly. And then on the outside, we'll want to test some points too. So maybe we'll try 3 and 4. Negative 2, negative 3. And again, the goal here is to figure out, are we above or below the horizontal asymptote as we are at those values? Now, we'll want to be careful. We can get some weird behavior. So you might want to try some values closer, maybe 2.5 or 2.1. So if we do h of 3, really all we're going to check for is it positive? So if we think of the ratio, well, 3 in the numerator is positive. And then both denominator values are going to be positive. So this is going to be a positive number. And then h of 4, same thing. So that's going to be positive as well, which means we're going to be above the axis somewhere. So that means we're going to get a branch that is above the axis. Something like this. And then following towards 0. And then similarly, if we did negative 2, and negative 3. So negative 2 is going to give us a negative over a positive, because we'll have a negative in our numerator, and then we'll have a negative times a negative, which is positive. So this is going to be some negative number. Same thing for h of negative 3. So our graph is going to be below. And what you'll notice here is that you're typically going to get opposite behaviors, so positive and negative infinity, unless we've got lots of squares. So if we had something like x squared here, then this is actually going to look like a parabola instead. So we'll see that in future examples. But I would say definitely plot some points to kind of gauge the behavior. One thing to note, though, is we can cross our horizontal asymptote. So we can have something like this, where it crosses but then heads back towards 0. So definitely be careful of the points you choose. So let's go ahead and look at number 4. So for number 4, we've got some squared behavior now. So we have a square in the numerator, square in the denominator. Again, we'll factor this expression. And then begin the same process. So you might want to pause the video here and try to graph this one on your own. So we'll see nothing cancels, so we're not going to have any holes. For the y-intercept, if x is 0, it looks like we're going to have negative 18 over negative 4. So it's going to be 0, comma 9 over 2, or 4.5. For zeros, we've got negative 3, 0, and positive 3, 0. Asymptotes are going to be x equals negative 2 and positive 2. Then we've got another horizontal asymptote. Don't worry, slant asymptotes are coming. And this is going to be the ratio of the leading coefficients. So we've got two squared terms, so it looks like 2 over 1. So that's going to be y is equal to 2. All right, so now we're going to be ready to graph this function here. So let's maybe tick mark off a few spots here. So asymptotes are now symmetric. So that might imply that we've got some symmetry here. So now we've got 2 and -2. So let's just do a quick check of our symmetry here. So f of -x is going to be 2 times -x squared minus 9 over -x squared minus 4. Obviously, the squares aren't going to change signs, so this equals f of x. So that means this is an even function. So if we remember back from our review unit, even symmetry means we're going to have symmetry about the y-axis. So that means this is going to look the same on either side. So that's a good piece of information to have as well. Let's go ahead and continue with our asymptote information. So we've got our horizontal asymptote at y equals 2. And then we just need to plot some points here. So let's see, we've got zeros at -3 and +3, so that's nice. And then 0, 4.5 is going to be up here. And that's actually kind of enough to tell us the information because we know that we are going to be symmetric. So what we're going to end up with is, oops, a graph that's going to tend towards 2 on the extreme left and extreme right, but then it's going to decrease to -infinity. And then in the middle, we can see that we're actually above that horizontal asymptote, and we're going to stay above that because we've got even symmetry. So on the right, we'll get positive behavior, and we'll get the same thing on the left here. So we get this parabola shape in the middle and these 2 branches that are symmetric on either side. Again, if you're unsure of it though, right, check some points. So you can check additional points for those behaviors, etc., to just verify them. All right, so we'll go ahead and pause here after finishing these 4 examples, and we'll come back and we'll finish the remaining few examples. So